Let's get started on this part 2 video. For this video, there's a few more problems than the last one, so I already did a lot of the work. I'm more or less going to explain what I did as concise as possible, so please stop the video, work the problem out yourself if you need to better understand it. So let's begin. For this problem, it's very context specific. So a ball is thrown, seconds pass, and then you're trying to figure out what's the max height of the ball. So what that is you're really just trying to find the vertex. Here's to find the x of the vertex. So all I did is I plugged in the a and the b of the function that was given to me. I did the math, and then 4 came out. And then to get the max height, you plug in 4 into this function, and then you should have gotten 32 out. So it took 4 seconds for this projectile to reach a max height of 32. And that's as easy as it is. Okay, next one. To find the vertex, remember, all you have to do is set the numerator equal to, the vertex. I don't know what I said. To find the intercepts, first to find the x-intercept, you need to set the numerator equal to 0. I got x equals 3. And then for y-intercept, there's none. Okay, so in this case, if you would have plugged in 0 at the bottom, this whole thing would have became 0, and we can't have that, remember? So now, to find the behavior of near each x-intercept, you look at how you got the x-intercept. There's a multiplicity of 1, which is odd. So at x equals 3, the graph crosses. Okay, to find asymptotes, again, the vertical one is always the easiest one. You set each factor of the denominator equal to 0, and I got 0 and -1. For the horizontal, remember, all you care about is the largest exponent of the x on top and bottom. So here we have -x on top, so it's really an exponent of 1. And on bottom, if you were to distribute these two right here, you would have ended up with x cubed. Since the denominator, the power of the denominator is bigger than the numerator, then you have a horizontal asymptote by your rules at y equals 0. To find the behavior near each vertical asymptote, remember, this is going to be taken off the graph, so you don't really need to answer this one. And then determine where f of x is above or below the x-axis. That one is best done after you graph it. So let's go ahead and focus on the graph here. So as you can see, I already set it up. So I have the above or below, but there's nothing there. First, you want to graph, okay? This is the only place I'm going to really talk about how to graph this function using test points. So please make sure you do the problem on the side and then work it out so that you get what I get. So right here, I have to test a point to the left of -1. So I'm going to test -2. I have to test a point here because if the value is positive, then my graph is up here. If the value is negative, my graph is down here. And then you always want to test a point to the left of the intercept and to the right of the intercept. So in this case, I would test the value here. You're going to find out that it's positive, and then to the right is going to be negative. Again, because of time constraints, I already worked this out beforehand. So this gave me a value that was negative, meaning the graph is below. This gave me a value that was positive in between. Okay, that means that it's above. And this gave me a value that was positive to the left of 3, but then it became negative to the right of 3. So if you plug in 4, it should have come out negative. If you plug in 2, it should have came out positive. So this is what happened. Just to recap one more time, although we have a horizontal asymptote, your graph could technically cross through and only through the x-intercept if you have one, okay? Okay, so that means to answer the above and below. So where's your graph above and where's it below? So it's above in this interval, and it's below, and it's above also in this interval, but it's below in this interval and 3 and later. So again, let's actually do the algebra. So it's above between the asymptote -1 and the other vertical asymptote 0. Union, it's above between 0 all the way up to 3. And you normally don't include it in brackets because usually the asymptotes get in the way. So just do the above and below in parentheses always. And then below is from negative infinity, as you see on the left, all the way to my first asymptote at -1. And then union, it goes below again, the 0 after 3, so from 3 to infinity. Okay, so again, above and below means above the x-axis, below means below the x-axis, and that's it. We're done with this problem, all right? Okay, we're going to cover this one as well, and we're going to break it up. So this first part right here is going to be solving the f of x. So once more, what does f of x behave like? Whenever you see behave like, is really just talking about the simplest polynomial possible. You make sure to include the negative if it's a negative in the front, and then you count the number of x's. So here we have 2 plus 4, and that's 6. Turning points is always 1 less than the degree. The degree is the total number of x's you have, and then -1, that's your turning points. X-intercepts is always going to be, remember, set these equal to 0, and you solve for x, so we should have 3 and -2. That's what we have here. Y-intercept is always plug in 0, right? Do the math. It should have been 144, but go ahead and check me. If it's wrong, let me know. But I think that's what I got. Okay, so what is the behavior near each x-intercept, at each intercept? It's always referring to, what is it, bouncing or crossing at the x-intercept. So because they're both even, they're both going to touch and bounce. You could just say touch, but if it's odd, you have to say it crosses, right? Touch and bounce always go together. Some people do touch and cross. No, that you're mixing both of them together. So again, you could either say touch. If you don't want to say bounce, that's fine. But cross is only when it's odd power. So both of these, x equals 3 and 4, the graph touch and bounces because they're both even. Cool. Now let's graph it. The first thing to graphing is you have to have the end behavior correct, meaning where's the arrow pointing. I already know that it's negative in the front and it's even. Because it's even and negative, both the arrows should be facing down, okay? So my touching and bouncing and all that stuff should make sense. So if it really starts over here, then when I get to -2, it should, again, touch and bounce, crosses the y-axis somewhere. I see if it's going down, that means this should have probably been -144, most likely, right? But it's okay. So then I go up to 3, and then I touch and bounce, and then I go down. Yeah, so most likely what I did is I forgot to multiply by this first negative, so that's probably should have been -144. Cool? And then you're done. Okay, doesn't have to be super crazy in terms of how you draw it. Okay, this one. Again, real quick review. This one, you never want to do work like that. You need to factor it, okay? And then step number 1 is factor. Step number 2, put the factors on the number line. Step 3, open or close circle on the intercept. So we're gonna have 9 here, and then we're gonna have -4 here, and then they're both closed because they're both a numerator, right? They're both numerator, and also this is greater than or equal, so they're both gonna be closed. Now I'm gonna test point 0. That's always the easiest one if you can, and my outcome should be -36 is greater than 0 if I plug that in, and that's false. So here it's gonna be false. Then it alternates because both of these have a degree of 1, so it's gonna alternate because it crosses. So that's true and that's true. So my answer for this is going to be from -infinity to -4 union 9 to infinity. Cool? Okay, so let's move on to this next one. This one was just like the other one, right? So I'm not really going to go over this. I'll leave the screen here for a second so you can pause if you want to go over it. And then I'm not really going to do the graph because I feel like I'm reaching my limit here in terms of time. This is the one that I want to focus on, and hopefully it keeps me under 15 minutes, but I wasn't keeping track of time. All right, so again, find intercepts, behavior near each intercept. My x-intercept was just 1. when I set that equal to 0. My y-intercept was 1 over negative 16 when I plugged in 0 and did the math. And so at x equals 1, the graph crosses because it's got an exponent of 1 there. And then my vertical asymptotes, again, behavior near each asymptote. Don't worry about this. Just graph the function. I will see that you did it correct and give you credit. So vertical asymptotes, again, set the denominators equal to 0. And so vertical asymptote is -4 and 4. Next one is find the horizontal asymptote. Again, it's -x over x squared when you multiply these two together. So again, the denominator is bigger, so by default your horizontal asymptote is at y equals 0. Well, that was actually supposed to go over here, but it's okay. And then the next part is determine where f of x is below or above, right? Again, don't answer that one until you graph the function. It's always going to be easier that way. After doing some test points, again, you do test points 1 to the left of -4. This is the intercept right here, so you want to do a test point right here. Well, one of these values, a test point right here, and then a test point over here as well. So again, I already did some test points. So when I tested a point to the left of -4, the graph went like that. When I tested in between -4 and -1, the graph went negative, and then after 1 to the right here, when I tested this, it was positive. So the graph crosses through that x-intercept, and it was positive. And then the last one to the right of 5, you should have gotten negative, and you should have a graph like that. Again, the only thing that you need to for sure have, so that you have all the minimum components, is the asymptotes, horizontal, vertical, and then write the x-intercept and then the vertical asymptote numbers like I did, the 1 and then the -4 and 4. Okay, so I've graphed it, so I did E. Now you do D. So in this case is where's the graph below or above? So just do above and then below. Okay, so above was from -infinity all the way up to -4. That was above. Okay, and then union, and then 1 to 4 was above, right? So the 1 to 4 is the fact that it was here, but it's stopped by this asymptote. And then below, it's going to be -4 to 1, and then union 4 to infinity. And that should be it. Again, pause, rewind, replay, do what it is you need to do to really get these down. But I hope this helps.